All right, in this video, we're going to be talking about linear combinations, which are something that we are going to be very interested in this course. And like a lot of things in linear algebra, it's got a somewhat complicated looking definition, but it's got a very simple concept. So if we've got a set of vectors, v1 through vn, and a set of scalars, a1 through an, if we take a1 of v1 plus a2 of v2 all the way up through an of vn and add them together, this would be a linear combination of those vectors. So the idea is, okay, I'm going to take this many of the first one, that many of the second one, some other number of the third one, and some specific number of each of the vectors in a set, and I'm going to add them all together and see what I get. Okay, this is going to be something, I think you'll see the connection even in this video, but we'll take this and go pretty far with it. So the example I've got, just for the sake of the video to get started, is write the vector 1 and negative 4 as a linear combination of 1, 1, which I'm going to call A, and negative 3, 2, which I'd call B. Okay, so first I think I'm going to write down what I mean by what do I want to do when I'm writing this vector as a combination of the other ones. Okay, I'm going to say I want to be able to write 1 and negative 4 as some number of 1, 1s plus some other number of negative 3, 2s. And I'm just going to happen to call those numbers x and y. Okay, and then if I look closer at this, I could actually distribute in the x and the y, and then also add the vectors together to get a vector equation that looks a little something like this. And then if I look at this, okay, what this is telling me is that I need x minus 3y to equal 1, and I also need x plus 2y to equal negative 4. Okay, and if you look at this, this is a system of linear equations. Okay, and we have quite a bit of experience with this already. And so since this problem is equivalent to a system of linear equations, we're going to solve it the same way we would solve a linear system of equations, which is to say, with row reduction. That's kind of a big theme in this course, row reduction, and that's kind of a theme in mathematics, is, transform a given problem into an equivalent problem that we already know how to solve and use that technique against this new thing. Okay, so what I'm going to do is, when I was trying to solve a system of equations, I augmented a matrix and row reduced. So what I'm going to do is I'm going to create an augmented matrix. Because if you think about it, that's the way that we were combining, the way we were writing out the system. X minus 3y equals 1, and x plus 2y equals negative 4. Okay. And then we're going to row reduce, so I'm going to take row 2 and subtract row 1. And I'd get that matrix. And then I think I'd mentally maybe divide row 2 by 5, and then add 3 copies of that up onto row 1. I might be a little more careful, but you don't need to watch me do the row reduction here. And I'm going to get that. And what this is telling me is that x equals negative 2 and y equals negative 1. Okay. So if I go back to the original idea of, can I write this vector 1, negative 4 as a linear combination of 1, 1 and negative 3, 2, using that same equation I'd written, what this is telling me is yes, you can. If you use negative 2 of this one and negative 1 of that one. And let's just see how that would work. Okay, that's going to be negative 2 plus 3 negative 2, and there you go, 1 negative 4, just like we were hoping to show. Alright, now we've got a different direction this can head. What if I asked you to write this as a linear combination of 1, 1 and 3, 3? Okay, this should be pretty quick to row reduce. I would, set up like I set up the last one. And I'd go and I'd subtract row 1 minus row 2. Then I might, actually I probably don't even need to do that. You don't need to see me take it all the way to reduced row echelon form. You see 0 equals negative 5, and there's no solution. So I'll conclude that it's not possible. 1, negative 4 cannot be written as a combination of 1, 1 and 3, 3. I think I've got a little bit more to say about this. 1, 1 and 3, 3, if we combine these in any way, I'm going to end up with a product that has the first and second components that are equal. Okay, just try any number of A plus any number of B, and you will get a vector where the two components are the same. Okay. So I probably wouldn't want 1, 1. I wanted 4 and 4. I want to write 4 and 4 as a linear combination of these, because I think you can see one very easy way But if you think about it again, you might realize that there's more than one way, right? I could obviously take A plus B and get 4 and 4. But I could also take 4 of A and none of B and get 4 and 4, and that would be just as legitimate of a linear combination. So if I wanted to find all the possible linear combinations, I would set up just like I had. Whoops, that would not be going well for me. Here we go. We've got all of that, and okay, that means I've just got 1, 3, 4, and then a row of all zeros. Okay, that means since I had 2 columns to have pivots in, and I only had 1, I am going to have infinitely many solutions with a row of all zeros and not having no solution, evidence elsewhere. Okay, so that means that x plus 3y equals 4. Right. So what I'm saying is that we can say 4 and 4 can be written as x of 1 and 1 plus y of 3 and 3, where x plus 3y equals 4. Well, maybe I'll just solve for x. X equals 4 minus 3y, and that means y can be whatever it wants. And I chose that just because y was the one that had the coefficient of 3 against it, right? Y didn't have to be the free variable. But if I take, let's say, y to be just some constant k, then x will need to be 4 minus 3k. And you can check that this is going to be true. I didn't leave enough room, but I can take. If you decide how many of 3, 3 you want to take, you take 4 minus 3 times that number of 1 1s, okay, to get the vector 4, 4. If you actually think about it, the way I said it, that actually makes a lot of sense. Okay, so we will be talking a lot about linear combinations in this course and working with them and stuff, but for now I just wanted to get you an idea of what they were and how to write one vector as a combination of the others. So that's all for this video. Thanks for watching.